Hello and welcome to another episode of Anything Arduino. So I barely finished editing the last video and then I had already planned a whole new episode if you saw the last episode, we made this really simple and cheap Arduino Bumper Robot, which is a really small program, loads of computer space or programming space for other sensors and stuff. The bad thing is that the motors are actually taking up 8 of the 13 digital ports. So we don't have very many digital ports left to play with for sensors and other stuff that need digital ports. So in post-production I thought about another video I did a while back where we used 595 74HC595, that's the full name of it, to serially control a 7-segment LED display. Same thing we can do here. We can serially send a signal using only 3 pins to 595, which in turn will either put high or low its 8 output pins. And if you remember in the last code, it was in Mahanad's function for each stepper, it was actually those 4 pins for each motor was just high and lows. So it will be just the same using the 595, but we will do a bit of that binary math again, and with that we are hopefully going to be able to drive both our motors on only 3 pins. So let's do a recap on the binary math and how we're going to do this, and then let's go into the code. So I hope you have seen my other video where we used the 595 to display numbers on a 7-segment LED display. If you haven't, I suggest you go and see that first. But let's anyway go through what an 8-bit shift register does anyway. So 8 bits is 8 positions that can be either a 0 or a 1. And each 0 and 1, this is binary counting, it is called. So the first 0, the least significant bit, can be either 0 or 1. And the second can be either 0 or 2. And then we double this all the way up, so 4, 8, 16, 32, 64, 128. With this, just by setting this to 1, we can count all the way from 0 all the way up to 255. We do this by setting this to 1, and then all the others are 0, so we have 1, and then we do a 0, 1, and we have a 2, and then we have a 1, 1, and we have 3. See, and then we have 0, 0, 1, we have 4, and then we add the 1 again to the 4, and we have 5, and then we add the 2 and the 4, we have 6, and then we add all these 3, we have 7, and then finally 0, 0, 0, 1 is 8, and then we continue that up all the way. This is how computers with transistors count. It's a very powerful way to count, so can't stress that enough. So what we do now is we will take the 4 least significant bits to one motor, and if you remember in the code, what we actually did, we just made all these ports, the 4 ports on the Arduino. On the chip here we have in 1, 2, 3, 4. We make them high and low in a specific order, which triggers the spools inside the stepper motor and thus making it turn. So what we'll just do is we will copy the how do you say, the pattern in the program doing binary math. So I have that one right here. I have taken the liberty of already doing this. So motor 1 and motor 2. So for first position we have, this is in the opposite order anyway, but 1 1 1 0. So 1 1 1 0 is 8 12 14. So it's 14 in the first position. And in the same way, for the second motor, motor 1 and motor 2. In the second motor, 0 1 1 1 will be 64 96. Sorry about that. 96 112, right? 112. So just, I'm spacing out here in my binary math. Let's do this in the code instead. Let's finish this. So what you do is then you add 112 to 14, and then you add the sum of these two numbers to the 595, which in turn will tell this chip, or both these chips, what to do. So anyway, let's go into the code and let's try to explain it better there. Okay, so we are going to do a few alterations in the code here. I have prepared the setup for doing a 595. So we're actually going to remove these, and instead we are going to do this. So once again, if you haven't, you should watch my other 595 video. But so we have the latch pin on pin 2, data pin on pin 3, clock pin on pin 4. So 3 pins. We will not need these pins either. That is enough. And so now we've set up our serial output. And now in the steppers, this is what we are going to change. So let's just write a small notation here. Motor 1 is 8421. Remember the 4 least significant bits. So in 1 is 1, in 2 is 2, in 3 is 4, and in 4 is 8. In value, that is how much they are worth. So instead of writing this, we are going to write 8. So we'll have a variable called stepper 1 value equals 8. Let's add that to our stepper 1 val and stepper 2 val. And these are ints. So let's just go through all these.
So this is 8 plus 4 is 12. Nothing, nothing, 4, right? And this is 2 and 4, so 6. And this is just 2. This is 3. And this is 1. Oops, sorry. 1. And this is 8 and 1, so 9. I hope you are following along, just counting binary, that's it. And this is actually 0. There.
And then we have the stepper 2. And guess what? This will be called stepper 2 val. These are for the 4 most significant values. So these are 16, 32, 64, 128. So that is how it should be, because this is 16 and that is 128. Just the same as up here. This was 8. So that's why I write it like that. This is then 128.
And this is, oops, 128 and 64, so 192.
Now, if you get this wrong, nothing will work, because one of these digits in the wrong place and all the ones and zeros get garbled up.
Easy one. Thank you for that. It's always harder in the high numbers. 64 and 32 is 96. And 32 and 16 is 48. Forget to delete. And this is only 16. And this is 128 plus 16, so 138, 144. And the default is still 0 though.
There. So this is done. Nothing else is, we're only changing these values. So up in the loop, what happens is that every time we call the stepper function, stepper 1 and stepper 2, before each time we call the function, it actually moved the stepper forward 1 step. This doesn't happen now because now it only counts for the 595, so it's just a binary count for how the steps should move, but they never do move. So what we do is, after each block of stepper 1 and stepper 2, 1 step each, which keeps track of the direction of the steps and the counting of the steps. So we add 3 lines, which I just copied from our other video episode with the shift out. So we digital write the latch pin to low. That allows us to shift out on the data pin with the clock pin speed. Most significant bit first, which means the highest bit first, just it's one order. And we take the stepper 1 val plus the stepper 2 val, so the high value and the low value of the 2 steppers for the 4 bits of the first stepper and the 4 bits of the second stepper. So those 8 bits together we send as one value, shift that out, and then when we are done we put the digital write the latch pin to high, which will in turn send this value to the output pins, the digital output pins of the 595, thus moving both steppers one step. So we need to add these 3 lines to all the places where we have stepper 1 and stepper 2 like this. So we go down here when we turn right. And this is the default for moving forward. So there. So I've removed the other breadboard on all the cables from the bumper robot and just put this in here. The only thing that is connected is the bumper pins, which are 2 new bumper pins, number 5 and 6, because I used 2, 3, 4 for the shift out. So they are connected via a 10K resistor to ground. And then we will connect the bumpers directly to the pins. Like that. And then to +5. We have +5 there. So the bumper pins are back connected. And let's start with the shift out. So pin 2 on the Arduino is the latch pin, and that should be connected to DS. Sorry. Latch pin 2 should be connected to number 12, STCP. So this is 8, 9, 10, 11, 12. Pin 3 on the Arduino, which is the data pin, should be connected to DS. So number 14. And finally, the clock pin, pin 4 in this case, should be connected to pin 11, SHCP. And then we need some power. +5. Connected to pin 16. And ground. Take ground down here. Connected to pin 8. And then we have a few special pins here. Let's take blue for that. We have pin 13. Needs to be to ground. Don't remember what that was called though. And then also pin 10, which is master reset, needs to be high at all times for this to work. So pin 13 to ground and pin 10 on the 595. This is to 5 volts. And now we can connect the motors. So we have in 1. So this is a bit specials that I've connected this wrong, I see. First motor in number 1 should be connected to pin 15. So 1, 1 to pin 15. And then in 2, 3 and 4 on motor 1 should be connected to pin 1, 2 and 3 on the 595. I don't think you see very much now. It's very crowded in here. There. And the same goes for motor number 2. Just get my cables in order here. So we continue in number 1. We just continue down the row. It's pin number 4, 5, 6, 7. It's the pins 1 through 4 in order. So 5 to pin in 2 to pin 5, in 3 to pin 6, and in 4 to pin 7. There. Starting to get quite a lot of cables here. And then power. Right. So, and we want the voltage out as well here. So we connect ground to both motors. Like so, and then we connect power there and take voltage in pin to there. And now we should be done. So it is moving, and seems to work. Great. A bit rickety, I think you say. Could be because of the power. Yeah, works. Perfect. So with much less pins, the robot is working just as before, but much more pins freed up. And with this, we finish another episode of Anything Arduino. This episode we did two things that we've done in previous videos. We used the bumper robot we did in the last episode, and also we just set up a shift out program and incorporated that in the bumper robot sketch, which we did in a episode long back. This is a good thing to know, that you can do other things with the 595, and this opens up really a lot of possibilities for having a lot of motors driven by a Arduino. I mean, with the 595s you can serial connect these, so you can actually have just as many Arduino 28BYJ-48 motors as you want connected to an Arduino with just 3 pins. So with that said, I'm guessing that as the digital or binary number gets higher and higher, it will get slower and slower. I can't really say that this did any difference on the speed of the robot itself. So in this case, with only 2 motors, it worked great. So I hope you liked this, and well, let's see if we can make some more interesting stuff with this robot. And I have tons of other stuff as well to do. So more episodes to come. Please subscribe so you will get notified when they arrive. And if you have any questions or suggestions or things like that, just comment below. And if you make one of these, once again, I want to know. It would be fun to see more of these around. And until next time, take care. Bye.